So before you can say that pressure is going to have an effect on a particular reaction, all the reactions involved must be gaseous. So what is a reversible reaction? A reversible reaction is one in which both the forward and backward reactions are occurring at the same rate. A reaction in which both the forward and backward reactions are occurring at the same rate. Let's look at this now. If you look at this, this is the reactant. This is the reactant, and these are the products. This is the products. Are we following? Now, this reaction, this sign shows that this reaction is a reversible reaction. That is a reaction in which the forward reaction and the backward reaction are taking place simultaneously. They are taking place at the same rate. Are we following? So this sign means that this reaction is what? A reversible. But if you have an arrow just like this, it shows that the reaction is just forward reaction only. But when you have double arrow like this, it shows that the reaction is what? Forward and backward. Therefore, it is what? A reversible reaction. Are we together? Okay. So now let's look at equilibrium constants. Let us write the equilibrium constant of this reaction. Equilibrium constant, to write the equilibrium constant is simply product over reactants. Product over reactants. So let's write the chemical equilibrium of this. So beginning with the product, you have NH3 raised to power 2. Now this 2 is talking about the moles. All over N2 multiplied by H2 raised to power 3. Are we together? So you have to take note of the moles. So NH3, the product, it has 2 moles, the superscript, all over N2 multiplied by what? N multiplied by H2 raised to power 3. Are we together? Let me give you one more. Assuming you have something like Ma plus B, reversible reaction gives you NC plus MC plus KD. Are we together? So this is how to write your equilibrium constants. Now let's look at these other concepts. Exothermic reaction. What is exothermic reaction? Exothermic reaction is one in which heat is exposed to the atmosphere. One in which heat is exposed. Heat is exposed or heat is evolved. Heat is exposed or heat is evolved to the atmosphere. And it is denoted with negative. So when you see a reaction like this and it has negative, it tells you that this reaction is exothermic. Heat is what? Evolved to the atmosphere. Then endothermic reaction is one in which heat is absorbed. Endo, heat is absorbed from the surroundings or from the atmosphere. It is denoted with positive. So when you see enthalpy change is equal to positive, that tells you that the reaction is what? Endothermic. Okay, so let's quickly go to the effect of temperature, concentration, and pressure on a chemical equilibrium. So let's look at effect of change in temperature. Now this particular topic is very important for your Jamb chemistry because examiners love questions from this topic. Now let's look at this. Remember, when a reaction is endothermic, the enthalpy change is positive. And when a reaction is exothermic, if it is exothermic, the enthalpy change will be what? Negative. So for an endothermic reaction, that is the one that has plus, increasing the temperature will favor the forward reaction. Now when we talk about forward reaction, we are looking at what? The product. So if we say this favors the forward reaction, what's the forward reaction? The product. If we say it favors the backward reaction, what's the backward reaction? The reactants. Are we together? So increasing the temperature of an endothermic reaction will favor the forward reaction, whereas decreasing the temperature of an endothermic will favor the backward reaction. Let's look at exothermic. Exothermic reaction is reaction in which heat is evolved to the atmosphere. So exothermic reaction is denoted with enthalpy change of negative. Now what happens to temperature? What is the effect of temperature in an exothermic reaction? In an exothermic reaction, increasing the temperature will favor the backward reaction, while decreasing the temperature will favor the forward reaction. Please, you need to know these at your fingertips. Are we together? Very important. So let's apply it here. Examiners are going to ask you, what is the effect of temperature on this system? Then you will see questions like A, it is this. It will lead to the formation of this. B, it will lead to the formation of this. C, it has no effect. D, they will put another nonsense for you. Are we together? Okay, so let's look at this. Now, this reaction is a positive reaction. Positive means that it is what? Positive means that it is endothermic. So, increasing the temperature of this reaction, if you increase the temperature of this reaction, it will lead to the formation of more nitrogen 4 oxide. Are we together? But if you decrease it, it will lead to the formation of more of the reactants. Look at this. Increasing the temperature, look at the enthalpy change, positive. So increasing the temperature will favor the formation of the products. It will lead to the formation of these products. Then decreasing the temperature will lead to the formation of these reactants. Number 3, look at this. This is negative. Now what happens to exothermic? Increasing the temperature of an exothermic favors the backward reaction. So if you increase the temperature of this system, it is going to favor the backward reaction. There will be more production of the reactants. But when you decrease the temperature, it will lead to the formation of the products. So finally, look at this. What is the effect of temperature on this? This is negative, exothermic. So if you increase the temperature, it's going to favor the what? The backward reaction. And if you decrease the temperature, it is going to favor the forward reaction. Please endeavor to memorize this. It's going to help you. So you can easily say, for an endothermic reaction, increase in temperature favors the forward reaction. But for an exothermic reaction, increase in temperature favors the backward reaction. With this, you can easily remember it, and you know that it is vice versa. Are we following? So please endeavor to memorize this. Okay, so let's look at effect of pressure. Now, if you notice, I wrote gases here. What does it mean? Effect of pressure only affects gases. It only affects species that are gases. So before you can say that pressure is going to have an effect on a particular reaction, all the reactions involved must be gaseous. Are we together? Okay, now let's look at this. Is there going to be effects on this reaction? The reactant must be gaseous, the product must be gaseous. Yes, pressure is going to have effects here. Let's look at this. The reactant is liquid and the products are liquid, and I think this is gas. Is it going to have effects? Is pressure going to have effects? No. Why? Because there are other states here. Pressure is only for gases. All the species must be gaseous. Look at this. Gas, gas, gas. Is it going to have effect? Yes. Look at this. Gas, gas, gas. Is it going to have effect? Yes. Are we together? So you have to be able to know which one gas is going to have effect on and which one is not going to have effect on. So from this analogy, from what we saw, we discovered that gases is not going to have effect on this reaction. Now for gases, the enthalpy change has nothing to tell us about the effect of pressure. For gases, the side that has the least number of moles, for gases, the side that has the least number of moles will be affected by increasing pressure. Will be affected by increasing pressure. So the side that has the least number of moles. So let's look at this. This person is going to be affected by gases because both the reactant and the product are all gaseous. So which one has the least number of moles? This is 1 and this is 2. So the one that has the least number of mole is what? Is the reactant side. So if you increase the pressure of this system, it is going to favor what? The reactants. Are we following? Let's look at this. This is 2 plus 1. This is 2. So 2 plus 1 is 3. If you increase the pressure of this reaction, if you increase the pressure of this system, where is it going to favor? It is going to favor the one that has the least number of mole, which is 2. So it is going to favor the what? The forward reaction. Are we following? Okay, look at this. This is 1, this is 3, and this is 2. So 1 plus 3, 4, and this is 2. So if you increase the pressure of this system, it is going to favor this side. That's the what? The product side. Are we following? So increasing the pressure of a gas, it must always favor the side that has the least number of moles. Please take note of this. Memorize it. Increasing the pressure of a gas favors those that have the least number of moles. Are we together? Okay, so let's look at effect of concentration on a system. Okay, now for concentration of a system, it depends on what you increased. Are we together? So let's say you increase the concentration of the reactants here. Increasing the concentration of these reactants will lead to the formation of more products. Are we following? But decreasing the concentration of the reactants will favor the backward reaction. So it is going to lead to the formation of more reactants. Let's look at this. If you increase the concentration of these products, of these reactants, it is going to lead to the formation of more of the products. Now, what happens if you decrease the concentration? It becomes more dilute. It is going to favor the backward reaction. In other words, it is going to lead to the formation of more of this. Look at this. Increase the temperature, increase the concentration of these reactants, it will lead to the formation of more steam. But decrease the concentration of these reactants, it will lead to favor the backward reaction, leading to the formation of more of the reactants. The same thing is applicable here. Are we together? Okay, so let's look at the last but not the least, effect of catalyst. What is the effect of catalyst? Remember, a catalyst alters the rate of chemical reaction and remains unchanged at the end of the reaction. It is not affected. So what will happen if you put catalyst here? Will it favor the forward reaction or the backward reaction? It's not going to favor anything. Why? Because a catalyst is there to just alter the rate of the chemical reaction and remains unchanged at the end of the reaction. So what will be the shift in equilibrium if you put your catalyst here? Basically, there will be no shift in equilibrium. Why? Because a catalyst alters the rate of your reaction. Are we together? So no matter the catalyst you add here, all of them, the shift in equilibrium will remain constant. There will be no shift in equilibrium. So shift in equilibrium is only affected by temperature, pressure, and concentration. Please, this topic is a little bit dicey, so make sure after watching this video, go back and replay so that you understand it very well. This topic is a most loved question by examiners. Okay, so we've come to the end of today's class, and I hope you found value in this class. Don't forget to subscribe to our channel and also invite your friends to do the same. All right, so quickly move over to the next video on air and pollution. Thank you for watching. Bye.